Hi, everyone, and thank you for joining us. My name is Madison Earhart, and I'm on the marketing team here at AgileThought. Just a little bit about us. We're a custom software development and consulting company that works primarily with Fortune 1000 clients. We help enterprise companies envision, deliver, and maintain software solutions that are critical to their business. We were also recently named a finalist for the 2019 Microsoft AI and Machine Learning Partner of the Year Award, and we're really excited about this recognition. So today I'm joined by our presenter, Jose Chinchilla, and he is our data analytics practice lead here at AgileThought. So during this webinar, Jose is going to teach you the benefits of Azure Data Lake Gen2 and Azure Data Factory V2, as well as how to save time building a big data analytics solutions. So before we begin, just a few housekeeping items. We're randomly going to select 3 lucky winners to receive a 1-hour consultation with Jose. So the winners can use this consultation as an opportunity to discuss their data migration project to Azure. They can also discuss different migration strategies with ETL workloads to Azure and discuss data lake implementation. And we're going to email the winners after the webinar with next steps to get those consults scheduled. So now I'm going to hand everything off to you, Jose.
All right, thanks for that introduction, Madison. So like Madison mentioned, I lead the data analytics team here at AgileThought, and I've written a couple of books and have earned several certifications, including the MCSE, MCSA, and the latest one, Micro Certified Trainer. So I'm happy you can join us today. So today, we're going to be short and sweet. We're going to talk about some of the data lake design considerations for your organization. We're also going to talk about Azure Data Lake Storage Generation 2 and Azure Data Factory version 2, and just recap some of the high-level benefits and capabilities of both services. And then we're going to do a quick demo on how to load Azure Data Lake Store Generation 2 with Azure Data Factory version 2 using the new data flow, which is still in preview for Azure Data Lake. So why Data Lake? Historically, organizations collect lots of data for their day-to-day operations, including sales, transactions, CRM, financial information. And most of this data has been historically structured data. And when I mean structured, it's typically in some type of relational SQL database, as well as some other sources, including web services, web applications, and so forth, that most likely have some type of structured schemas behind that application. In recent years, there has been an influx of lots of different formats and variety of data, including social media data, video, images, sound, and text documents that are not easy to structure in a relational type of database. So combining all this structured and unstructured data along with the volume of data, this is why there has been a shift in the way we structure our analytical stores, typically like a data warehouse, and moved more into a data lake type of analytical storage. Now, with that said, now we can enable our data analysts to connect to all sorts of data through a common storage. They don't have to go through different places, different connections to be able to aggregate all this data and be able to derive analysis and insights from it. Differentiator between a data warehouse and data lake. These are the 3 important points, comparison points to keep in mind. The data warehouse typically has been created with a schema already defined, has already a structure, and already has data that's been processed. Typically, you go through an ETL process where the data it gets extracted from the data source, transformations gets applied, and then they are written into a predefined data schema. As opposed to a data lake, which accepts any type of data, be structured, unstructured, and doesn't have a predefined write schema. And typically when applications connect to a data lake, they will connect and define a schema at the time of read. And this is defined, commonly known as a schema on read. In addition to that, in order to scale and have high availability disaster recovery in a data warehouse, you need to have a plan in place. You need to be able to forecast the growth of your data warehouse, the number of users, and the performance, and your SLAs, and plan all that out beforehand. With Data Lake, and specifically with Azure Data Lake, you have unlimited scalability. Essentially, you can grow into petabytes or even hexabytes of data, as well as support a high number of users, and the performance and the throughput will also scale linearly along with the storage. In addition to that, you have already all the high availability disaster recovery built in from Azure services, from locally redundant storage to globally redundant storage that you can synchronize your data to other data centers around the world. One of the big design considerations when it comes to a data lake is the architecture you're going to put in place, along with the file format, content, physical design security, and the frequency of the data you're going to be loading. So these are the four most important design considerations that I have gathered from all the data lake implementations we've done. Specifically, in architecture, we're talking about consolidating all this data into a single data lake, or are we creating multiple data lakes, so sometimes referred to data ponds, where you have small data marts or small sections of your data for specific divisions or business units. In addition to that, as part of the architecture, you need to consider what data needs to be available almost immediately or in real time versus data that can undergo some transformations, some staging, some processing, and not be as real time as other data. And in that architecture, you implement what are known as hot or cold streams. Hot for being that more real time, more recent data, and cold stream for that data that undergoes some type of processing that is not made available immediately to the users. And when I talk immediately or real time, we're talking about under 5 minutes, under 10 minutes. That depends on your organization. In addition to that, we talk about the file format and content. Is the content of this data going to be in a raw stage, in a process or semi-processed stage, as well as what is the format of the files. Typically, most organizations choose a comma separated value or text delimited file format, but there are more advanced type of format that are geared to faster performance, such as Parquet, Avro, or some JSON, XML binary type of files. So that depends on the use case and the tools that you're going to be using to connect to this data. In terms of the physical design, one of the considerations here is how are you going to organize your data. Now with Data Lake Store Generation 2, we will find out in a little bit, you can actually define a file system with a hierarchy defined. So folders, subfolders, and files. And then you have to also consider the security aspect. How are you going to secure the data? Are you going to open it up, the entire data lake to the entire organization? Or are you going to be very prescriptive on who has access to what different type of folders? And you can achieve this now with roles or access control lists, just like in regular file systems. And then the frequency, like I mentioned, is this data going to be loaded kind of in a real-time type of scenario or use case? Or are you loading this data in an hourly, daily type of fashion? So all these considerations come into play when you architect your data lake, from how immediate the data is going to be available, how you're going to write the data, to how you're going to secure it, and how often are you going to load it. In terms of Azure Data Lake Storage Generation 2, there are some new features and capabilities that have been added. And part of these capabilities is the combination of blob storage along with ADLS or Azure Data Lake Store Generation 1. So Microsoft brought the best of both worlds together into what's now called Azure Data Lake Storage Generation 2. And one of the biggest improvements here is that now you support, or Microsoft supports, the ability to add a hierarchical namespace, essentially a file system with directories, subdirectories, which allows you to define very granular security, both at the service level or at the file system directory level, down to the file level, if you want to be very granular. And all of these supported with role-based authentication, access control list, and a superset of POSIX permissions. In addition to that, part of this hybrid best of two worlds of blob storage and ADLS is the ability to tier your storage, both in capacity, in terms of how much data you're going to store. Like I mentioned, you can scale up to exabytes, but also the throughput that goes along with it, and the high availability disaster recovery. So all of this is built in and supported in Azure Data Lake Storage Generation 2. So now, why is it important to talk about Azure Data Factory when we're talking about loading a data lake? So Azure Data Factory, as you may already know, is a data integration, ETL or ELT type of web service, where you can run, schedule, run, and monitor pipeline execution. And currently there's two versions. Version 1, which is the first iteration, didn't have a rich user interface to develop pipelines. But now with Azure Data Factory version 2, which is the current version, you have a rich web-based development environment with a very rich and intuitive user interface, similar to SSIS in the way you drag and drop activities or transformations into your workspace, and then connect them to create a control flow or data flow. Talking about data flows, which is still in preview, this is the ability to create very logical step-by-step transformations on your data. So again, very similar to SSIS. And Azure Data Factory uses Azure Databricks as its compute power. So it is very scalable. You can add transformations to massive amounts of data, and Azure Databricks in the backend will parallelize and scale this for you. One of the great additions into Azure Data Factory capabilities is the ability to not only connect to cloud or web-based data sources, but also on-premise data sources using what's called the self-hosted integration runtimes. And if you already have a lot of workloads, a lot of work and effort into SSIS packages, you can actually deploy SSIS packages to Azure Data Factory version 2 and execute them, monitor them, just like you will from like SQL Agent or the SSIS catalog. More specifically, talking about some of the features of Azure Data Factory version 2, is the idea of developing what are called pipelines, similar to SSIS, like packages. And the pipelines contains one or more activities. It can contain a specialized activity, which is in preview currently, called data flows. And it utilizes data sets as a source or a destination to load, extract, and then load the data into. And these data sets are defined by link services, which are like connection managers that allow you to define things like to what type of source system are you connecting to, credentials, and then be able to define data sets from those link services. And then at the end, we also have the integration runtimes, which we talked. These are specialized compute systems that allow you to either do some work over a data source or kick off some jobs in other specialized systems such as machine learning, Databricks, Spark, etc. So with that, we're going to jump into our demo, and we're going to load a data lake using Azure Data Factory version 2. So what I have here is I have a SQL Server data source, which I have my sales order line, sales orders. And what I'm trying to do for my sales team is to create summary files every day about who we sold our products to, what products, when did we sell them, and the amount of their orders. So for that, I'm going to extract the data from this SQL database, and I'm going to load this Azure Data Lake storage. This is a ADLS Generation 2 type of storage account, and I have a file system here where I load data from my finance team, and then I break down that data into different folders such as budgeting, financial, forecasting, planning files. Marketing team as well, we have some folders defined for them. And then for our sales team, several folders, specifically the sales summary folder, which is empty at this point. So I'm going to create a pipeline in Azure Data Factory that will extract a summary of the data from our relational database and create a file system here that our salespeople can navigate through and be able to get to the data they need. So with that said, I'm going to open my Azure portal. In my Azure portal, as you can see, I have a Data Factory. And this is a Data Factory version 2. Once I click on Azure Data Factory version 2, I can click on my Author and Monitor shortcut, which will open my authoring and monitoring environment in Azure Data Factory. So I'm going to go into my Author section, and I can see several artifacts that I have here in my Azure Data Factory. I have pipelines, I have my data sets, data flows, and templates that I can create. Specifically, today we're going to talk about a pipeline that I created called the sales summary with data flows. And this pipeline is a very simple pipeline that allows me to define transformations on my data and be able to aggregate them, look up data, and then load my Azure Data Factory. So what I have here at a very high level, I'm going to describe at a high level what we have in this data flow. And then we're going to kick off this pipeline and wait for the data to be created. And then I'm going to go a little bit into the details while it's loading. So the first thing I have here is two data sets, sales orders, sales order lines that I'm joining. You can see that the join here is a inner join on my order IDs. Then I have my aggregate where I'm grouping data and aggregating. Then I'm looking up the customer names, product names. And then I'm deriving the file name that's going to be generated and loading it into my Azure Data Lake Store folder. In this case, the data is going to be loaded into this file system called demo FS under my sales summary folder. And what you'll see here is a bunch of directories that I'm going to explain while it's loading. So at this point, I'm going to kick off this pipeline by clicking the debug button. As soon as I click the debug button, I can see that my pipeline is executing and it's telling me what steps it's running. So right now it's running my audit log start process, which records when this pipeline got executed and also some metrics on how long it will take once I log my the end of my execution. So while this is running, I'm going to go back into my data flow. And this is a very simple pipeline. Like I mentioned, joining these two data sets together and then doing an aggregate. And an aggregate is essentially like doing a group by. These are my group by columns. So, and then I have my aggregates, which is a very simple mathematical expression using the expression language in Azure Data Factory. This is a different syntax than SSIS or syntax in other languages that you've seen, but it's a very simple language syntax. In this case, I'm multiplying quantity times unit price from my sales order lines, and then I'm summing that data up by my group by columns. In this case, my stock item, my product IDs, sales order, and order date. Now that I have that, I want to look up my customer name. And in here, I am referencing a customer data set as my lookup stream, which is down here. And as you can see, as I hover this, it highlights both the actual data set and the reference to the data set. Similar to product name, sorry, I'm using my product data set, and it's being referenced, my lookup, to look up my stock product name. At the end, what I'm doing is I'm creating a derived column, and that derived column is called file name. And what that file name is, if you look at the expression, although it seems a little bit complicated, we can see very quick the output of that expression. And that expression is essentially deriving the hierarchy that I'm going to be writing to, and the actual file name that's going to write to the Azure Data Lake store. So we're going to wait for that to refresh, and we should see the example of the file names that's going to be created. So while that's refreshing, because probably it's competing with the actual pipeline execution running in the background, let's look at our Azure Data Lake store and refresh the data here. We see that it already created the folder structure that I'm looking for. And for example, we can navigate to 2016. It also created folders by date. And then we can see in one of these folders, the sales order line summaries created for each of these daily folders. This is sample data coming from White World Importers database. So there's no transaction for every day of the day, but for those days, you can see that there's a file created, and we can actually download this file, and we're gonna see the contents of the file. We should be able to see the data in our files that we generated. So that's the CSV file that we downloaded. And we can see, we can consume that data really easily in Excel. And we can see the output. We can see the order date, order ID, customer name, sales amount, stock item name. And then if you see the data, all these orders were the orders for the May 2nd, 2016 date, which are all stored in the May 2nd, 2016 file inside my 2016 year. I could create a more complex hierarchy here. So I can do year, and then I could do months or quarters, and then break those down by day. I could also just create 1 month and have a daily file under that month. So this is very flexible, and you can programmatically do this using the expression language as I was showing you here. So while our pipeline execution completed, we can see the output of this. We can open this really quick in like Notepad. And we can see that for these different order dates, this is the file name it created. And we can confirm that that was the actual file names that were created as well in the hierarchy that we defined under sales summary. So that is a very quick example of how we can load a data warehouse, having all the data logic, all the transformations in our data flow, and then dynamically generating a file name that we can write our data. And it will follow that hierarchy based on this syntax in our expression language, and then load it into Azure Data Lake store. There's other options that we can have for loading Azure Data Lake. The one I defined is the file name option was generated as part of data in a column from my data. And that is from that file name variable or field that I generated in my derived column here. But there's other options here where you can have Azure Databricks, which is the compute power behind the scenes, generate your file names based on the default settings for Azure Databricks, based on a pattern or partition, or just consolidate everything into a single file. That is, if you want to hand this off perhaps to a machine learning or data science team, and you want to just give them one file with all the data consolidated, so they don't have to traverse through multiple files. But in most cases, data lake stores will be defined like this, where you have some type of subject area or division or bucket, and then subsequent subdirectories or folders for more specialized areas for analysis. And then typically you would have a year, month, date, year, quarter, month, date, etc. As your file system hierarchy. So that's the very simple execution of a Azure Data Factory pipeline to load a Azure Data Lake store. And that concludes the demo for today. So we're gonna go back to our questions and answers. And I think Madison has also some exciting for those who want a 1 hour consultancy with me. Madison?
Thanks, Jose. So we actually received a few questions in advance from you all, so we can try and get through as many as we can. And if we don't get to your question, please, again, email us at marketing@agilethought.com. So Jose, the first question we have is, what incremental loading and partitioning strategy do you recommend with Azure Data Factory and Data Lake?
Great question. So in terms of incremental loading, one of the big topics is detecting changes from your source systems. Several source systems, for example, SQL or other relational databases, have built-in mechanisms to track changes over time in your data. For example, SQL Server has change tracking or change data capture, as well as Oracle and other vendors, platforms. In addition to that, if you don't make use of those change tracking, change data capture mechanisms, you can build your own incremental loading logic. That could be based on a transaction date or some metadata columns. For example, if you're storing the time that that record was inserted or was edited, and you can make use of those metadata columns in your data sources to derive your own incremental loading and change tracking logic. Other systems don't have that change tracking mechanisms or those metadata columns available. So the only option there will be to stage your data and then do comparisons against your existing data in your data lake, doing things like hash columns that will identify if there's a change in a particular column or row of data. Other mechanisms that you don't actually have to track changes or identify changes, you only append data that has changed, kind of like in a journal type of scenario. So there's several options there, but you have to have some type of incremental loading along with some change tracking, change data capture mechanism.
Okay, great. Thanks, Jose. And moving on to our next question, does Azure Data Lake support file formats other than plain text or CSV?
Yes, so in the demo I showed that CSV or text files with comma separated values. You can have other delimiters as well, spaces or tabs. But in these files, you can have more specialized type of file formats, like I showed in my slide deck initially. One of the most common one is Parquet in Avro, but there's other like org and just plain JSON files and binary files that are typically used. But that all depends in use case and the tools that you have available to connect your data lake. Not all tools support Parquet or Avro type of files out of the box. So that's a big design consideration, looking at your tool set and the capabilities of those applications or tools. So for fast reads, I would recommend Parquet. But you will need to have some type of deserialization process where either you stage that data in text file for your users or some type of interface that allows to read those Parquet files into a more readable format for some of the tools that users are utilizing.
Great. Thanks for answering those, Jose. So that concludes today's webinar. Thank you all for attending. And we're going to send you this webinar recording in case you'd like to share it with your coworkers or your friends. And we will also be following up with the 3 winners of our consultation with Jose. And if you have any questions, please send them our way. And we all hope you have a great rest of your afternoon. Thank you, everyone.
Thank you.